Good morning, Miss Heraldizo. So we are the group 5 and the topic that we are going to discuss is about metamodel. So what is metamodel? A metamodel is a model that defines the structure and relationship of other models. It serves as a template or framework for creating specific models within a particular domain. Metamodels define the entities, attributes, and relationships that can be used when creating instances of models. They provide a higher level abstraction, guiding the modeling process and promoting consistency and interoperability within a given context. In various fields such as software engineering, system integration, or data modeling, metamodels play a crucial role in standardizing and organizing the model concepts. So here are four structures of metamodel, namely class metamodel, entity relationship metamodel, feature metamodel, and behavioral metamodel. Now, let us discuss each structure metamodel. And the first metamodel is the class metamodel, which is discussed by Sherilyn Padilla.
In object-oriented modeling, a class metamodel defines the structure and relationship within a system. A class. A class is a blueprint for creating object. It encapsulates data or attributes and behaviors or methods that define the characteristic of the object instantiated from it. Attributes. Attributes are properties or data members of a class, representing the characteristic that object of the class can have. They define the state of an object and can have different data types. Relationships. Relationships in a class metamodels describe how classes are connected or associated with each other. Common types include association, aggregation, and composition. Associations represent connection between classes, while aggregation and composition describe stronger relationship with different levels of ownership. Together, these elements form a foundation for creating models that represent the structures and behavior of a system, facilitating effective software design and development.
The entity relationship metamodel is a conceptual framework used in database design to represent the relationship between entities in a system. Here is a brief overview of the key components of the entity relationship metamodel. Entity represents a real-world object or concept. Can be a person, place, thing, event, or concept with distinguishable characteristic. Typically corresponds to a table in a relational database. Attributes describe a property or characteristic of an entity. Attributes provide details about entities and contribute to their definition. Example include name, age, or address. Relationship describe how entities are related to each other. Relationship indicate association, dependencies, or interaction between entities. Example include works for, owns, or is part of. Cardinality specifies the number of instances of an entity that can be related to another entity. Common cardinalities include one-to-one, one-to-many, and many-to-many. K. Identifies a unique attributes or combination of attributes that uniquely identifies an entity. Primary keys are often used to inform entity uniqueness. Weak entity. An entity that cannot be uniquely identified by its own attributes alone, relies on a relationship with another entity known as its parents for identifications. Relationship degree define the number of entities participating in a relationship, can be binary or two entities, ternary or three entities, and so on. Role describe the part an entity plays within a relationship, specifies the function or purpose of an entity in relationship to another entity. Associative entity, a type of entity that is created to represent a many-to-many relationship, contains attributes that capture additional information about the relationship itself. The entity relationship metamodel provides a standardized way to represent the structures and dynamic of a database system, aiding in the communication between stakeholders involved in the design and development process.
Feature Metamodel. Feature Metamodel plays a crucial role by providing a structured representation of the features and their interaction within a system. It helps architects and developers understand how different components or modules interact, ensuring seamless interaction and efficient system functionality. This metamodel aid in the design phase, allowing for a clear delineation of features and their relationship, ultimately contributing to a well architecture and integrated system.
So the behavior metamodel is a concept that commonly used in software engineering and system analysis to represent and describe the behavior of a system of software applications. So it provides a structured way to define and analyze the interaction, activities, and processes that occur within a system. At its core, the behavior metamodel consists of sets of models that represents different aspects of behavior. So these elements includes actors, use cases, scenarios, elements, actions, and also state machines. So actors are entities that interact the system of software being modeled. So they can be users and external system or any other component that initiates or participates in behavior. Second is use cases. So use cases represent specific interactions or tasks that an actor perform with the system. They describe the functional requirements and specify the behavior of a system from the perspective of the actors. And the third one is scenarios. So the scenarios provides detailed description of how a use case is executed step by step. So they captured the sequence of actions, decisions, and events that occur during the execution of a specific case. And the fourth one is events. So events are occurrences that trigger or affect the behavior of the system. So they can external stimulate and such as user inputs or message from other system, or internal events like timers or system generated notifications. So the fifth one is the actions. So actions represent the operation of tasks performed by the system in response to events or as a part of system behavior. So they capture the processing logic and transformation that occur within the system. And the sixth one is the state machines. So the state machine describes the different state that a system or an object can be in how it transitions between those states in response to events. So they capture the dynamic behavior and help in modeling complex workflows and state-independent actions. So the behaviors meta model provides a systematic approach to captured and represent the behavior of a system. So which aids in requirements analysis, system design, and system verifications. So it helps stakeholders understand and communicate the expected behavior of the system. So I and also identify the potential issues or conflicts and ensure that the system meets the desired functions requirements.
How useful Metamodel in system integrations and architecture is. Metamodel play a crucial role in system integration and architecture. offering several benefits that contribute to the overall success and efficiency of these processes. Here are some key advantages of using Metamodel in system integration and architecture. Shared understanding and consistency. Metamodel act like a common language, ensuring everyone understand and talk about system in the same way. Automation of model-driven development. Metamodel set rules for creating system model, automating code generations to save time and ensure precision. Interoperability between systems. Metamodel provide common rules for different systems to communicate seamlessly, improve analysis and decision making. Metamodel create clear models helping decision makers analyze and choose system design. Enhance cybersecurity risk assessment and management. Metamodels help organize cybersecurity concept, aiding in effective risk assessment, ease of maintenance and evolution. Metamodels act as evolving reference, making it easy to update and understand system changes over time. Metamodels are highly valuable in system integration and architecture, offering a standardized and structured approach that enhance communication, automation, interoperability, and decision-making process across the entire system development life cycle.
Purpose of Metamodel in system integration and architecture. In system integration and architecture, a metamodel serves as a conceptual model that defines the structure and relationship of various elements within the system. It provides a higher level abstraction, helping to standardize and describe the components, their properties, and how they interact. Meta models aid in understanding, designing, and implementing complex systems by establishing a common framework for communication and collaboration among stakeholders. They play a crucial role in ensuring consistency and coherence in system integration, enabling effective planning and analysis throughout the development life cycle.
Example of meta models in system integration and architecture. Meta models in system integration and architecture define the structure and relationships of various models used in a system. Here are some examples. Number one, Unified Modeling Language Meta Model defines the elements and relationships used in UML diagram, ensures consistency and standardization in representing system architectures and behaviors. The second one is Meta Object Facility Meta Model. Defines a framework for creating meta models used to define meta models for various modeling languages, promoting consistency and interoperability. Third one is Service Component Architecture Meta Model. This describes the structure and relationships of components in a service-oriented architecture. It defines how services are composed and interact within the ACE framework. The last one is Business Process Model and Notation Meta Model. It specifies the elements and relationships for modeling business processes, and it ensures a standardized representation of business processes for communication and analysis. So these meta models establish a common understanding and structure for the models used in system integration and architecture, promoting consistency and facilitating communication between various tools and components. with a system.